Section 7.1, example 2, solving a system of equations in two variables by graphing. Solve the following system of equations by graphing. Identify the type of system. So again, we mentioned that we could have a system with one solution, a system with no solutions, or a system with infinitely many solutions. So let's start graphing. So we'll do this first one, equation 1 in gray. And we'll see what we could do equation 2 with. So just drawing a graph. And with equation 1, let's solve this using our intercepts. So solve using intercepts. Let's find our x-intercept first. So 2x plus y equals -8. For our x-intercept, we're setting our y equal to 0. So 2x plus 0 is equal to -8. 2x equals -8. Divide both sides by 2. We have x is equal to -4. This equation gave us the point -4, comma 0. So over here, we'll say that's 2 and 4. 4, 0. And now let's find our y-intercept. So for our y-intercept, we're letting x equal 0. 2x plus y equals -8. So we're just letting x be 0. So 2 times 0 plus y is equal to -8. Y is equal to -8. So this gives us the point when x is 0, y is -8. So here we have 2, 4, 6, and 8. And from here, we're going to draw our graph. So trying to draw it as precise as possible so that way we could get an actual solution. Some of the downfalls of graphing for a solution is even the tiniest movement could actually mess up your solution, but we'll try our best. So we have that for our first equation. We'll work on the second equation here. Let's do the same thing here. Let's solve using our intercepts. So for equation 2, let's start with our x-intercept. So for our x-intercept, we're setting y equal to 0. So x minus 0 equals -1. We have x equals -1. So when x is -1, y is 0. So when x is -1, y is 0. That gives us that point right there. And now let's try for our y-intercept. So for our y-intercept, we let x equal 0. So let x equal 0. We have -y is equal to -1. If we multiply both sides by -1, you get y equals 1. So when we plug 0 in for x, our y is 1. So that gives us this point right up here. And now from here, we're going to try our best to graph. So trying your best to get as precise as possible. And now this ends up being our intercept. It kind of feels like it might be -3 here. It looks like it might be like a -1.2, but just to round up, let's try -1. So -3, comma -1. We're going to have to plug this into both equations just to make sure that it's a solution to both of the systems. And hopefully it is. Hopefully we don't have to do any more work other than that. So now we're going to check with equation 1 first. 2x plus y equals -8. 2x in this case is going to be that -3 plus y in this case is going to be -1. And this should be -8. -3 times 2 is a -6 plus a -1 equals -8. Ooh, it looks like we messed up. Oh, I see the problem. These are all done by 2's. So this isn't -1, this should be -2. So let's try this one more time. So 2 times x in this case is -2 plus, nope, -3 plus y in this case is -2, and this should be equal to -8. We have -6 minus 2 equals -8. And it looks like it works for this solution. But just like in the previous problem, we have to make sure that it works for both equations because we might just have a solution for one of the systems and not both of them. So let's try problem or line number 2. X minus y equals -1. So x in this case is -3 minus y in this case is -2 equals -1. We have -3. Our negative times negative gives us a positive here. So +2 equals -1. And it looks like we have the right solution. -1 equals -1. So here our solution and what we end up boxing in is going to be -3, -2. That's the solution to this system of equations. And they also wanted us to identify the type of system. So we have a solution to the system of equations. So we have something that's consistent. If you have any questions, please feel free to ask. Otherwise, bye.